Hey everyone, welcome back to the channel. If you're someone who wants to crack system design interview or want to become a solution architect or system design architect, right? Then you need to understand the basics of system design and all the basic concepts you need to understand. So, as I already told, we are going to start with our RGB system design playlist. So this will be our second video of this RGB playlist. Today's video we are going to start with the first topic, like what is system design and what do you mean by distributed systems and why it is so important. So let's start with that. So if you want to build, let's say, scalable applications, then understanding system design is a must thing. In this video we will break down the core thing or the core of system design in the simplest way possible. So stay with me. The first question, what is system design? Now if you think, system design is all about designing systems that meet some specific criteria, right? I mean, it's not just about a system is not just about front end and a back end server. You writing some APIs and then sending the response to the UI and just showing it in a beautiful UI. It's not only about that. When your system grows, you need to meet some specific criteria in your application. All right. Let's say uh, your application grows to millions of users or billions of users. So handling millions of users becomes a must thing for your application. In those scenarios, you have to think about load balancing, distributed systems. This terminologies might sound jargons for you for now, but don't worry. We'll be discussing all these concepts throughout our playlist. All right. Then you need to ensure data consistency. Let's say you are playing with some stock market application, right? Let's say Grow or Zerodha, where the consistent data consistency is very important. As soon as some stock price moves, the same price has to be reflected across all the devices, whether it's laptop, whether you're using it in the browser or in the app or in the mobile app on tab. Data has to be consistent across, right? So that's about data consistency, and you need to obviously have as less latency as possible to make a smoother UX and accurate UX for your users. I mean, think of system design like, you're building a city, right? Where you need roads, electricity, then buildings that work together efficiently and completely build a good system for you, right? Okay. Now, if you just think about WhatsApp for a moment, just to picturize where system design comes into picture, just to visualize where system design comes into picture. So when you send a message, it should reach the receiver or the recipient instantly, right? So it on the surface it looks simple. You are sending a message, it just goes to the desired receiver instantly. But behind the scenes, there is a well-designed system that manages a lot of things. Like it ensures message delivery, then handles network failures, and it scales to billions of users. Handling a massive users is not a joke, right? So that's the system design in action for you. I hope you were able to visualize like where do the system design concepts come into picture. Okay, it's not just about front end or back end a server. In reality, it's a lot more than that. Now let's just discuss why system design is important. Now we knew what is system design, where we are using it, and now just think for a moment, why is it important, right? Let's say there is a Black Friday sale or Big Billion Day sale going on in a e-commerce application, right? Let's say Flipkart or Amazon. And suddenly, let's say the e-commerce site or the servers crashes. So that's a disaster for the application, right? A good system design ensures applications that are built, right? They are scalable, reliable, and performant. Like, what do you mean by scalable? Scalable means it can handle growing users. As the number of users search, let's say you're planning to buy an iPhone on the Big Billion Day sale at 12 a.m. in the night. So suddenly, a lot of users traffic come to your application. So your application should be scalable enough to handle growing users. Now, what is reliability? Reliability means it should ensure downtime, like your server should not crash. It should be responsive, even if the load is used. Now, the next thing is performant. Performant means keeps thing fast and responsive and smooth as smooth as possible without any downtime. So it's related to reliability in a way. Without system design, the apps that we are building or the designing, they would fail definitely. Okay, and when too many people will use it once. Now let's just discuss about the next jargon that you frequently hear in a technical world, that is a distributed system. Everyone talks about distributed system. I want to build distributed system, but what is distributed system? What do you mean by distributed? The term distributed. Who is distributing? How we are distributing? Those things must come to your mind, right? So if you think a distributed system is a system where components run in different machines, okay, and in the behind the scene they work, different components will be there running in different machines, but they work together as one. I mean, when the user is interacting with it, they would not feel like there are multiple machines go running behind the scene. They run multiple components run behind the scene to make the user experience smoother, make the entire application fault tolerant, make it scalable, and ensure speed. So instead of a single giant computer or machine handling everything, we distribute the task across many machines and then we connect. I mean, see, in this video we are just visualizing things, okay? We are not diving into how to do these things, like how do we make a system fault tolerant, how do we make a system scalable. Those along the way, when we will be discussing all the sections, you will gradually understand, okay? All the section we will cover, you will gradually understand those, but for now I'm just helping you to visualize the things on a surface level, on the high level. Just for example, think about YouTube, okay, where millions of users watch multiple videos at the same time. I mean, if a popular YouTuber publishes a video, millions of billions of people go to watch that video at the same instant time, right? So a single server cannot handle it definitely. What YouTube does, YouTube distributes the videos across multiple servers worldwide. Let's say you have multiple servers. I mean, here I have just added one server node, but it's not like that. For simplicity, I have added. Let's say you have number of servers in India, then you have number of servers in Japan, you have number of servers in Australia. So YouTube distributes videos across multiple servers like this worldwide. So when you play a video, it streams from the nearest available server. You are playing from India, then it will send a request to the Indian server and it will play the video for you. Just a surface level understanding. That's enough for the first video. So now, what are the advantages of distributed systems? As I told, we create distributed systems to make application fault tolerant. That means if one server fails, there will be other servers. Like as I told here, India में सिर्फ एक ही server नहीं होगा. There will be multiple other servers. So there will be a cluster of servers. So if one server fails, there will be other servers to handle the user request. Okay, the same user request. That's about making it fault tolerant. Second advantage is about the scalability. That means I can easily add as many node I want, all right, as the user demand grows. That's about the scalability. Next thing is about speed. Because we are distributing across multiple geographic locations, the videos or the request will be responded back faster, right? If you are serving the request from the nearest available node. Just imagine Netflix also. We all use Netflix, right? We use it to stream our favorite shows and movies. Now, have you ever thought, like, when you stream a video, how does it play that video instantly for us? You play it, it just starts a smooth streaming for you without any lag. That's where the distributed system concepts again come into picture. Behind the scene, on a high level, what Netflix does is it stores the copies of popular movies across multiple geographic location servers, right? Like this. And when you hit play, the video is streamed from the closest. Let's say I'm playing from India, my videos will be played from my Indian server, right? The server is present in India. So it ensures a smooth playback without any buffering or any lag. So that's a perfect example of a distributed system. To summarize, system design is crucial for building this kind of complex applications where a lot of criteria have to be fulfilled. Right now, I just discussed about some of the criteria, right? Message delivery, handling millions of users, data consistency, reduce latency. But there are a lot of other criteria also, okay? Along the way, when we'll be covering all our topics in our playlist, you'll get to understand about all the criteria. But that's what, I mean, is the end goal is to. That's about system design, and distributed systems help scale these applications to millions of users, all right? So whether it's social media, whether it's streaming, whether it's the e-commerce application, distributed systems are everywhere. They are the heart of any powerful system that you use or powerful application that you browse or use. So yeah, that was about the introduction video. I wanted to give you an overview and a glimpse of system design. Why do you need it and what is a distributed system? I hope you understood this well. If you found this video interesting, hit a like, and if you have any doubts, just put them in the comment section. I'll be sure to answer them. And please subscribe to my channel and follow this RGB system design playlist, where we'll be covering all the concepts one by one in a detailed manner in the most lucid and easiest way possible. That's all for today's video. Thank you for watching this video, and I'll see you in the next one. Thank you.